What's going on, you guys? Mr. Allen here with some fun and super dope application of logarithmic functions and exponential functions. I mean, it's gonna be awesome. All right, we got an earthquake at Snoop's house. He's okay, don't worry. Had a magnitude of 6.4 on that Richter scale. All right, and an earthquake when Dre was on vacay in Japan had a magnitude of 7.3 on that Richter scale. How much more intense was Dre's quake, right? Because that was more on the Richter scale. Now, here's the thing. Intensity is actually built into this formula here. We have our magnitude equals the log base 10. If there's no log base there, it's assumed that it's base 10 of the intensity over the standard intensity. Standard intensity would be 10 to the negative fourth, right? This would be given to you on a particular problem, right? We're not going to be applying this stuff all the time, but we want to see you work with logs, you know what I'm saying? Okay, so here's what we're going to do. We're going to work with two separate equations here. First one I got, I'm going to do, let's go with Snoop, all right? So Snoop's going to be over here. So Snoop's quake, all right, is a 6.4 magnitude, right? So 6.4 equals log base 10, or just log, of, we got our intensity, which is L over 10 to the negative fourth. We can just plug that bad boy right in. All right, so I've got a little equation here, and I can actually solve this for the intensity on the inside there. Check this out. This is log base 10, yes? Okay. It sometimes helps to write that because I'm about to loop and swoop this bad boy and write it into exponential form so that I can solve for the variable that is currently inside of that argument of the log. So when I loop that and I swoop that, right, we got 10 raised to the 6.4 equals the intensity. I change it to an L because I feel like it's hard to see I's when I'm writing in math. They look like ones, right? Over 10 to the negative fourth. So how am I going to just solve for that variable up there? Well, I can multiply by 10 to the negative fourth on both sides. 10 to the negative fourth. Woo! And now I have myself 10 to the negative fourth times 10 to the 6.4 equals out. Ooh, man. This seems like it's time to bust out that TI. All right. So we can just type 10 raised to the negative fourth times 10 raised to the 6.4. Hit enter. Woo! That's intense, bro. Right? So we got L, or I, or whatever it is, right, is equal to 251.1886. I'm going to go 188 ... Okay? Because I'm still going to be messing with that, right? In Yoro, you know, you only round once. So I'm still going to be messing with that. So I'm just going to jot that down. It's in my calc. We're good to go. Okay. Now we're on to Dre. Dre had a slightly different experience, right? It was more intense. Now, it doesn't seem that bad. It's like, what, 0.9 on the Richter scale more? But perhaps 'twas more intense. All right, so we got Dre going on in Japan. We can set it up the same. 7.3 equals, then we got log base 10, right, of the intensity over our standard intensity, which is 10 to the negative fourth. We got the same kind of looking thing, don't we? Except for that 6.4. So if you'd like, you can just go ahead and use your algebra that you already did, but I will show you a second time because I'm awesome like that. We got a loop and swoop. Whoop! We get 10 to the 7.3 equals our intensity over 10 to the negative fourth. I'm going to multiply by 10 to the negative fourth on both sides, 10 to the negative fourth. And now I can go ahead and plug this little bit right here into my calculator. And check this out. I'm going to arrow up. I'm going to hit enter. I'm just going to change that 6.4 into a 7.3. Hey-oh. Boom, hit enter. Oh my goodness. That is a way bigger number, dogs. That is our intensity equals 1,995.262 and change. So how much more intense was it? How many times more intense? That's probably how we'd ask it, right? How much more intense? How many times more intense? What do I do with those two numbers? I'm going to divide them. So I'm going to take that larger number and divide it by that smaller number to see how much more intense it was. 7.94. Let's see here. 7.94394 times more intense. That's cray, man. Dre's earthquake was a lot more intense. Right, there we go. So, all right, we use this logarithmic scale, so these numbers are a little more manageable, right? 6.4, 7.3. If I just started seeing like, hey, yeah, it was an earthquake, 1,995 today. Like, I might not know exactly what that means. Not that I know a whole lot about the Richter scale anyways, but that's what we do in the maths and sciences. We might use a different scale to bring these numbers down to a little more manageable things, but there's other parts to this. So that's pretty dope. You are now ready to be a seismologist. Is that what they do? Or whoever studies earthquakes and things. That might be it. I have no idea. Now I'm going to sound like an idiot, but whatever. All right. Hope you guys enjoyed it. I'll see you later.